All right, today's lesson we're going to take a look at um, linear relationships when you're talking about word descriptions. So most of the examples that we're going to see today, they will have the word description, and we're going to have to find the rate of change. We're going to have to find the initial amount. We're going to have to determine the equation, maybe solve some problems based on that. But the learning comes from identifying in each of the statements what is your constant, what is your rate of change, and in actually understanding what it means. So the first example that we're going to take a look at is um, yeah, exactly what we just did. So equations, tables, graphs, different ways of looking at them. So you're going to order a supersized sundae from Northwoods Ice Cream Parlor. It costs $5 plus 75 cents per topping. C represents the total cost, and N represents the toppings. Complete the following table. So we're going to interpret some of these things. So when we're looking at this, when we're talking about rate of change is comparing two units. So if we're looking at this, that's what's changing over time, the 75 cents. All right. And if we're looking at that, this means that we're being charged 75 cents per topping, or you could say it's 75 cents for each topping. So either way is fine. The idea there is we're comparing two units, money and the toppings. Well, there is a fixed cost here. We need the ice cream. All right, so it's going to cost $5. All right, so the initial cost is $5. Another way of looking at that is this is the cost for 0 toppings. The idea there is I haven't put any toppings on it yet, so we've taken the two scenarios and we split them apart. The hard part of this is probably making the equation. And you have to understand what's going to come first, the C or the N. Well, the cost depends on the toppings. So the cost depends on if we have toppings or not. And we know N M plus B. All right. What we do know that when we are writing this, that our rate of change for each topping, that's where that variable is going to come from. It costs 75 cents for each topping. That's where the N is coming from. And the B is my initial value here. All right. So this is my rate of change, or we call that our slope as well, but it means the same thing. All right. This is going to be the hardest part, is to determine where C and N are going to go with that. But it's based on that understanding. Now we end up solving a problem. What's the cost of sundae with 5 toppings? Well, if I look at that, well, toppings. What letter represents toppings? Well, if we look up here or we look up there, it tells us we have 5 toppings. Is N. We're going to find that. So we can use our algebra skills to type in what we know. Plus 5. All right, and then I can just use my calculator, and I can go 0.75 times 5. So $3.75 plus the sundae itself. There you go. So that's what we have there. So when doing some of these things, we want to be able to determine the cost per type topping and the initial cost and understand what they mean. That's the important part. All right. Martin's Taxi Service. It costs $5 to get picked up and then 80 cents per kilometer. And then we're going to fill out the table. C is the cost, and is the number of kilometers that you're driving. So what we're going to do is, using the information above, what I want you to do is push pause and see if you can fill in the first 5 things. So leave the word problem at the end, but fill in the rate of change, fill in the initial value, and fill in the equation based on the stuff that we just did on the first question. All right, so this is what I filled out. I said the 80 cents is my rate of change because that's how much change per kilometer. All right, or it's 80 cents for each kilometer I've driven. Either answer is fine. My initial value is B. B is 5. So the idea there is it's going to cost me $5 no matter what. All right, and then my equation is the rate of change times by the number of kilometers, n, plus 5. So if I'm looking at this, that's where my rate of change is going. This is my initial value. All right, where'd I go? All right, so the determined cost of 15-kilometer trip. Well, I can just put in 15 kilometers in there. All right, I can do 0.8 times 15. So that ends up being 12 plus the 15. It's going to cost me $27 for the 15-kilometer trip. There I go. So that's all we're kind of working on today, is the idea of, can I pick out from the description where is my rate of change, where is my constant, and sometimes it won't have a constant. That's fine, we can let that as 0. All right. Sometimes when you're answering questions down here, you're not always subbing in for n. Sometimes you're subbing in for C and solving for n. So be careful of that when you're doing some work today. All right. A couple more questions here. So Cameron, all right, she has $7,500 in her savings account. She spends $600 per week to rent a room for college. A represents the amount of money in the savings account, and N represents the number of months. So this one's probably a little bit different, but it's not bad. A represents the amount in the account as the number of months increases. So what's really happening? Well, when you're looking at this, is the amount of money increasing or decreasing? We know it's decreasing because we're spending that. So we know that our rate of change is decreasing by $600 per month because she's spending each month, or she spends $600 per month. We know that at the beginning she had $7,500 in her account. Initial savings of $7,500. All right. So when we make this equation, n is the number of months, so n is going to be multiplying by the rate of change. This is 600 negative 600 plus 7, because we know that this is a decreasing slope, or or decreasing rate of change. So the money is decreasing over time. All right. And we can do that by determining how much is remaining after each step. So if I was looking at how much money after a account, 8 months, all right, this would be the amount that's decreasing from the fixed amount. So I can take 7,500, subtract the 4,800, I'm left with 2,700 after 8 months. So one of the things here is just understanding that you sometimes might have a negative slope or rate of change. All right, so subtracting, decreasing, spending, all those are your negative rate of change. All right. Equation below represents the relationship between the mass of a block of ice, m, in grams, and the amount of time since the ice started to melt. So if I'm looking at that, all right, some interesting things that are happening there. The ice is starting to melt. Well, what should happen there? Well, I should have a negative rate of change because melting means it's decreasing. So yeah, you're right. The question now is, what does that -5 mean? Well, we have to look back at the question. Well, M represents grams, T represents minutes. So what happens here is that the mass is decreasing over time. All right, so this is actually decreasing by 5 grams, right? Because M is in grams, over or per 1 minute. Or another way of saying it is it's decreasing by 5 grams every minute, or it's decreasing by 5 grams per minute. Any one of those statements would work. And I screwed up. All right. There's my rate of change. Here's my initial value. All right. Here I started off with that. So the question we want to talk to ourselves is this going to represent 55 grams, or is this going to represent 55 minutes? Hopefully you said 55 grams. Okay, so this was my initial mass. Okay, and we can look at that when time is 0. So initially, well, if I did that, if I even looked at my equation, -5 times 0, well, that's 55. Oh, 5 times 0 is 0. Right, that makes sense. All right, so it's interpreting the information from the words and running away with that. All right, the last question we're going to take a look at is we're going to try to figure out which statement about this gym membership is true. So I have an equation. C equals 15N plus 100. It represents the relationship between the total cost of the gym in dollars and the number of months of the membership in N. So C equals cost, N is number of months. So one of the things we have to look at is they talk about initial cost, cost per month, a whole bunch of different things. But if I'm given this equation of 15n plus 100, what do we know? What do we know about this? Well, we know that our m is 15, so that was our rate of change or my slope. And what does that mean? Well, it represents $15 per month. Our B is 100. And what does our B mean? It's the initial amount, our initial cost, which is $100. So now we look at this and say, which statement is true? Well, is the initial cost $15? Is it cost $15 per month? Because it's only $15 per month, not $115. Is the initial cost $15 and is the fee of $15 per month? Is it an initial cost of $115 per month? Ding, ding, ding. You're right. So one of the things when it helps with multiple choice questions is writing down what you know. So by writing down your initial cost or your constant and your rate of change or your slope allows you to think clearly of which statement makes sense. Okay. So that's kind of the end of this lesson. But one of the things that we should be able to do is still identify a linear relationship from a word description and can identify the initial value, the rate of change, and understand what the equation is. So I should be able to do a lot of these things. All right. And can I interpret when it's necessary to have a negative rate of change because something is decreasing at a constant rate? So air, mass, that type of thing. All right, give the practice a go and we'll talk soon.